This video is about special products. So we aim to enumerate the different types of special product formulas to perform multiplication of polynomials using special product formulas, and lastly to distinguish polynomials in factored form where special product formulas or simply distributive property will apply. Now, there are certain cases of products of polynomials which has been classified because of the special forms of the factors. These products can be easily obtained by applying these formulas. So, the special product formulas is a technique used to facilitate the way of obtaining the product of polynomials in definite forms. We call this special products, special because we need not proceed or we need not use the distributive property in obtaining the products. We could just apply these special product formulas in obtaining those products. Now, there are 6 types of special products listed here. So, the first one is the product of two binomials. Second is the square of a binomial. Third is the product of the sum and difference of the same two terms. Fourth is the cube of a binomial. Fifth is the special case of product of binomial and trinomial. And then lastly, the square of a trinomial. So I guess the best way to explain this is by using examples. So let's try some examples. Okay, now for our first example, this will be for the product of two binomials. Now we're just going to follow the formula given in solving for the product of these two binomials. So, okay. So to name this would be our AX, BY, CX, DY. Now this should be equal to, let's try and write this down more clearly. So AC x squared plus AD plus BC times XY plus BDY squared. So we're just going to follow this pattern in solving for the product of these two binomials. So let's try it. So 2x minus 5y times the quantity 8x plus 7y. So R2 is RA, 5 is B, 8 is C, 7 is D. So we're just going to apply these values to our formula. So A, you have 2. C is 8. X squared plus A times D, 7. Oh, sorry. Oops. So this is A natin is equal to 2 times D, which is 7, plus B, which is negative 5. So let's place this as minus 5 times 8 xy. And then we have BD y squared. So B natin is negative 5. So this is negative. D is 7 y squared. So we could further simplify this. Let me just erase this one. So let's simplify this further. We'd get 16 x squared minus 26 xy minus 35 y squared. And that's the final answer for our first example. Now for our second example, we have a square of a binomial. Let's see. Let's try quantity 5x cubed minus 9 y raised to the 4th quantity squared. So here we're just going to follow the formula. So in our case, this is negative, so we're going to use this one. Okay? So in the square of a binomial, it is important to note that the result of the square of a binomial is a perfect square trinomial, which is this one. So to emphasize that in this in our squares, the first term is x and the second term is y. Thus, the square of the binomial comprises the following three terms. So the first one is the square of the first term, and then the second term is twice the product of the first term and the second term, and then the third term is the square of the second term. Okay? So let's try and solve this example. So 5x cubed minus 9 times y raised to 4, and the whole thing is raised to 2. So this is equal to x squared, which is 5x3 raised to 2, minus 2 times x, which is 5x raised to 3, times y, which is negative 9, times no, that's not negative, so we could just use 9 times y raised to 4 times x. No, there's no need to times x na. Okay na pala yan. And this is good. And then plus y squared. So our y is 9y raised to 4 squared. Yeah, that's it. So we could simplify this further. So we got 5 times 5 is 25. X is raised to 3 times 2, which is 6. Minus 2 times 5 times 9, which is 90. Times x raised to 3 times y raised to 4. Plus 9 times 9 is 81. And y raised to 4 times 2, which is 8. And that's the answer for example number 2. Okay, let's try a sample for the third type. Product of the sum of the difference, the sum and difference of the same two terms. This one. So example number 3. So let's see. Let's try something a bit more complicated. Let's try this one. So 4x cubed minus 9y raised to the 5th power times 4x cubed raised to 3 plus y 9 times y raised to the 5th power. Okay? So, if we multiply these two terms, this is just x squared. So our x in this case is 4x raised to 3 squared minus our 9, or our y is 9y raised to 5th squared. So simplifying this further, we'd get 4 times 4 is 16, x is raised to 3 times 2 is 6. That's minus 9 times 9 is again 81, times y raised to 5 times 2, which is 10. And that's the final answer for example number 3. Now example number 4, for a cube of a binomial. So let's try, let's try 2x raised to 4 minus 5 times y raised to 3 quantity raised to 3. So if we're going to use the formulas, we're going to use this one. Since this is negative, this is negative. So we have x raised to 3. So that is 2x4 raised to 3 minus 3 times x squared. So that's 2x raised to 4 squared times y, which is 5y cubed, plus 3x natin, 2x raised to 4, y is 5y raised to 3 squared. So maybe let's move this further in so we'd have more space. So maybe here. So we have plus natin negative y raised to 3, which is 5y3 raised to 3. Okay? So we just need to simplify this further. So we have 2 times 2 times 2, which is 8. X is raised to 4 times 3, which is 12. Minus 2 times 2 times 5 times 3 is 60 times x raised to 4 times 2, 8 times y raised to 3 plus 5 times 5 times 2 times 3, that's 150 times x raised to 4 times y raised to 3 times 2, which is 6. Minus, again, 5 times 5 times 5, 5 raised to 3 is 125 times y raised to 3 times 3, which is 9. So there you go. So that's the final answer for example number 4. Now for example number 5, or let's place a line here para we could separate this. Yeah. So for number 4, or rather number 5 pala to. This is number 5. Special case of product of a binomial and a trinomial. So let's see. Let's try. So for number 5, let's try 5x minus 3y times 25x squared plus, let's use something a bit more challenging. So let's try this one. So 5x squared minus 6y times 25 times x raised to 4 plus 30 x raised to 2 times y plus 36 times y squared. So using the formula again, so this one takes the form. So the product of a binomial and a trinomial is just this one. So x raised to 3. So we get 5x squared raised to 3 minus our y, which is 6y raised to 3. So simplifying this, you get 5 cubed is 125 x raised to 2 times 3, 6 minus 6 cubed, which is 216 times y raised to 3. And that's the final answer for number 5. By the way, you can get proofs of these answers naman by applying the distributive property. So it's like the long cut, applying your distributive property, and your special products formula is your shortcut. So you're just going to need to apply these formulas and you get the product of these terms. So last natin, square of a trinomial. So our last example number 6. So let's try, what should we try? So let's try maybe 6x minus y minus 2z squared. So first, we need to show this expression to mirror this one. So we need to make this negative signs positive. Diba? So 6x positive. Okay na yan. Plus negative y plus negative 2z, the whole thing squared. Tapos once we do that, we can now apply this one. So we have here, so a squared natin, which is 6x squared plus b squared, which is negative y squared, plus c squared, which is negative 2z squared, plus 2a 6x b negative y plus 2a 6x c is negative 2z, and then where are we? Plus 2b negative y times c, which is negative 2z. Okay. Now we just need to simplify that, and we get, so 6 squared is 36 x squared minus or plus y squared plus 4z squared, and then we have here negative 12 xy, and then we have here 2 times 6 times negative 2, so that's negative 24 times x times z, plus negative 2 times 2 is, so we have here negative 1. So negative 2 times negative 1 is positive 2 times 2. So that's positive 4 times y times z. And that's the final answer for example number 4. Now let's just highlight this para maybe something a bit bigger. Okay, I think we will move to factoring as our next topic. Okay, so our topic is factoring. So this section aims to enumerate the different types of factoring, differentiate one type of factoring from another type, and distinguish factorable expressions and factor polynomials completely. So basically, factoring polynomials is just the reverse process of special product formulas, the one we discussed earlier. So when do we know if a polynomial is no longer factorable? So we have two conditions. The first one is that the coefficients have no more common factor. And then the second one is it cannot be expressed anymore as the product of two polynomials of a lower degree. Okay? So you need to be able to meet these two conditions for us to be able to say that we have already factored down the polynomial. So, types of factoring. The first type is the common monomial factor, which is this formula. So, to apply this, let's tackle an example. So, we have here 18 times a raised to 3 times b raised to 4 times w minus 12 times a times b raised to 2. Now, what we need to do here is we need to determine the common factor so that we could get the common monomial factors. So let's write that down. So common monomial factor. So we can get the common monomial factor by getting the common factors of the different variables. So we have from 18 and 12. So we have 18 and 12. The common factor is 6. Then from a raised to 3 and a, the common factor is a. And from b raised to 4 and b raised to 2, the common factor is b raised to 2, right? Thus, the common monomial factor for this is 6ab squared. And then what we're going to do is we're going to divide this. Let me just copy it. Paste natin siya. Basically, we're going to divide this by its common monomial factor. So, what that entails is just you're going to multiply the whole thing by this. Wait, mali pala. So, dapat ito yung naka-parenthesis. There. So, from this, so what do we get? So, we get 6ab squared times quantity 18a raised to 3 times b raised to 4 times the value all over 6ab squared minus 12ab squared divided by 6ab squared. So simplifying this further, so we get, so we have here 6ab squared. So 18 divided by 6, we get 3. A cubed, you can't see it. A cubed divided by a, you get a squared. And then b raised to 4 divided by b raised to 2, you get b squared. Then you have your w. Minus 12 divided by 6 is 2. Our a's will cancel out. B squared will cancel out as well. So that just leaves us with 2. And let's see. So from our conditions, the coefficients have no more common factor. No more common factor. So base ito, 3 and 2. It cannot be expressed as a product of two polynomials of lower degree. I don't think we could express this any more simpler. So this is the final answer for our example. So let's just highlight this. So yeah. Okay. So let's try a different type of factoring. So difference of two squares. And in this case, ito yung ating formula. To better understand this, again, we're going to use a example. So we have here x raised to 4 minus 81 raised to 4. As a note here, if the obtained factors are not yet primes, we need to continue further factoring as we can see in this example. So in this example, so we have here, wait lang. So in this example, we could simplify this further as x squared raised to 2 minus 9y squared raised to 2. So that we could copy the format of our formula. Diba? So from this, since na-pattern na natin, we could copy this one. Diba? So, this can now be equal to x natin, x squared, plus y, which is 9y squared. And then x squared, minus y, which is 9y squared. Now, as you can see here, we could further simplify this. Diba? We're just going to follow again the pattern. So, this one remains x squared plus 9y squared. Now, we need to further factor this one by using this formula. So, we get x minus, I think we need to further simplify this one. So, I think, let me just write this. So, this one is just 3y raised to 2, right? So, writing it here, we get x plus 3y times x minus 3y. And I think that's the final answer for this example. So, simplest na siya. The coefficients have no more common factor. It cannot be expressed as the product of two polynomials with a lower degree. Oh, yeah, we've already met the two conditions for us to be able to say that we can no longer factor this. Okay? So, next type natin. So, let me just bring this up so that we could have more space. Yeah. So, sum and difference of two cubes natin. And these are the formulas that we're going to use. Pretty much, di ba, similar lang dun sa process natin sa special product formulas. Well, basically, they are the same formula. We're just reversing the process. So, okay, another example for this one. 64 times x raised to 4 times y minus x times y raised to 4. So, to solve this, the first step in this one is that we need to examine if there are any common monomial factors. So, in our case, what are the common monomial factors here? So, we have x and y. So, let's bring that out. So, you have 64 x cubed minus y raised to 3. And I think you could further simplify this one by, let's see, xy times 6 is just 4 cubed, right? 64, I mean, 64 is just 4 cubed. So we could express this in this manner. Y cubed. Para, if you would look at this, nag-fit na tayo dun sa pattern natin. Okay, now we could apply our formula na. So, applying the formula, we have xy times, so we have x, ito, x minus y, So we have 4x minus y times x squared, which is, maybe we need to erase this first. So we have 4x squared plus x 4x times y plus, I don't think we have enough space, so maybe we could move this further inside. Wait lang. Yan. Move lang natin, ha. Dito sa loob. So we have 4x times y plus y squared. So further simplifying this, you get xy times 4x minus y times 16 x squared plus 4xy plus y squared. Okay, so that's the final answer for example number 3, for type number 3, sum and difference of two cubes. And the next one, so let's write the next one. So our next type is perfect square trinomial. So let me write it down first. Okay, so we have a perfect square trinomial, and this is the formula for the perfect square trinomial. So we're going to apply this one in our example. So example, 2 times x raised to 3 minus 4x raised to 2 plus 2 times x. So we're going to factor this completely. So first thing, let's bring out the common monomial factor. In this case, it is 2x. So if we bring that out, we'd have x squared minus 2x plus 1. And I think this one completely follows, or rather this one completely follows this pattern. Diba? So we could now further simplify this as 2x times x plus, wait lang, I think there's a mistake in my example. This is positive pala. This is positive. Well, it can be negative naman din. So kapag negative siya, this is just negative y, which is in this case 1 raised to 2. So kapag ganyan. Okay? So our next type will be on the next page. Okay, so type 6 natin is other trinomials. So we're going to use this formula to solve for the factor. So this type is subject to a trial and error method because the sum of the products of the means and the extremes. So the means and the extremes, wait, maybe I could. The means and the extremes should be equal to the middle. So ito, means and extremes should be equal to the middle middle term of the given trinomial. So again, the sum of the products of the means and the extremes should be equal to the middle term of the given trinomial. So let's try that. So you have an example right here. So you have x raised to 2 minus x minus 6. So okay. From this set, factors ng x squared natin is just x times x, right? So that's pretty simple. So we could definitely say this is x, and this is x. So let's say this is positive tayo. Yeah, plus. Next, we're concerned with the factors of negative 6. So maybe let's write that down. So yung negative 6 natin, is actually equal to, what are the factors of negative 6? So this could be either positive negative 2, positive negative 3, or positive negative 1 times positive negative 6. So, ayan yung factors natin. So, reminder, kailangan yung sum of the products of the means and the extremes must be equal to the middle term. So, which one would produce a negative 1? Or rather a negative x. So, from this, I would hazard a bet that this one would produce a negative 1. You know, negative 3 minus 2, you'd get negative 1, right? In this case, you will not get a negative 1 from this one. So, I would hazard a guess that this is negative 3 and positive 2. So, let me just erase this first. So, erase that. So, I could definitely say negative 3, positive 2. Now, let's check. So, check natin. So, the product of the means, this one, 2x. The extremes, we have negative 3x. Sum it up. So, you have positive 2x plus negative 3x. You'd get negative x. And there you have it. So, this one, negative x, right here. So, we're good. So, okay yung factor natin. So, maybe another example. So, let's try, say, x squared minus 5x minus 6 equal to. So, x squared factor niya is just x. So, again, this is just x, x. So, hindi natin alam yung nasa loob. So, again, we're going to use negative 6. So, which factors of negative 6 are you going to use so that you get negative 5? Diba? So, I would hazard a bet that it is negative 6 and 1. So, you have here negative 6 and negative or positive 1. Para, if we're going to check, so you have negative 6x here, and then you have positive x right here. If we sum this up, you'd get negative 5x. And it's the same as the middle term. Yeah. Okay, so let's try another type of factoring. So, factoring by grouping. This is, wait lang. This is type 5 pala. This one is type 5. This one, type 6, is factoring by grouping. Okay, so polynomials consisting of 4 terms can sometimes be factored by the process of factoring by grouping. So this process is so named because it begins by grouping of terms within the polynomial and factoring such group. So I think it is best illustrated by examples. So let's try this. So the first example, we have ax plus ay minus bx minus by. So what we're going to do is first, we're going to group this. So by grouping this, so we can group this by, so you have ax here plus ay, and then you can say this is minus bx plus by, right? Then we could factor out a and b. So you'd have ax plus y minus b times x plus y, right? And we could further simplify this since these are a and a. For these terms, the common term is ito, x plus y and x plus y right here. So we could factor that out, diba? So that becomes x plus y times a minus b. And that's the simplest form of these expressions. So maybe another example. So let's say, so we have here x squared minus y squared plus 2y minus 1. Alright. So what can we do here? So maybe let's separate x squared. Tapos let's consider this as a our trinomial. So let's try. So from here, we have x squared minus y squared minus 2y plus 1. Okay, so since this is a perfect trinomial, as you can see right here, we could use this formula in factoring. So we could express this as, so you'd have x squared minus y minus 1 squared. And since this is still not yet at its base form, so we could distribute x squared. So we get x plus y minus 1 times x minus y minus 1. And then simplify this. Let's just remove the parentheses. You have x plus y minus 1 times x minus y plus 1. And there you go. So I think that is no longer factorable. Okay, so I just rearranged the writing. So nilipat ko dito yung type 6 factoring by grouping. So now we're on type 7, addition and subtraction of suitable terms. So this type of factoring is usually applied to polynomials with a degree of 4. So with two terms being perfect squares and both preceded by a positive sign. So through the addition and subtraction of suitable terms, the given polynomial with 4 terms of degree 4 will lead to the difference of 2 squares. So I think this is better illustrated by an example. So we have here an example. So we have x raised to 4 minus 14x raised to 2 plus 25. So from this, i-base natin siya sa dito sa dalawang terms, yung first and last terms natin. So we have here x squared minus 5 raised to 2. Okay, and this one is equal to x raised to 4 minus 10 raised to, or minus 10 times x raised to 2 plus 25. So ito yung gagamitin natin sa pag-solve. Okay, let's proceed with our solution. So this will now be equal to x raised to 4 minus 10 raised to 2 plus 25. Pero kulang pa tayo kasi you have here negative 14x times 2. So kulang tayo ng 4. So we're just going to minus 4 raised to 2. Diba? So from there, we could now simplify this further as x raised to 2 minus 5, the whole thing raised to 2. Minus, yung 4x natin can be simplified as 2x raised to 2. Yan. So, the next thing that we're going to do is, we're just going to apply this. So, yung positive and negative values nito dito. So, we have x squared. Let's see, positive 2x minus 5 times x squared negative 2x minus 5. There you go. So, that's the factor down of x raised to 4 minus 14 times x raised to 2 plus 25. Let's see another example. So, we have 4x raised to 4 plus 12 times x raised to 2 plus 49. So, from this equation, concern natin yung first and last terms natin. So, from the first and last terms, we get 2x raised to 2 plus 7. Then, the whole thing raised to 2. And this is equal to 4x raised to 4 plus 28 times x raised to 2 plus 49. So, we could use this to factor down this. So, what we're going to do is, ito tayo, 4x raised to 4 plus 28x raised to 2 plus 49. Ano yung kulang natin? So, this is supposed to be positive 12 times x raised to 2. And this one is positive 28 times x raised to 2. So, minus natin siya by 16. So, minus 16x raised to 2. So, now we could write this down as 2x squared plus 7 squared. Minus, so, simplify natin to 4x cubed. So, distribute lang natin to dito. We get 2x squared plus 4x plus 7 times 2x squared minus 4x plus 7. And there you go. Okay, last type natin. So, move ko lang to. So, for the last type, you're just going to follow the formula. So, type 8 is the sum and difference of two odd primes. So, in this type, you're just going to use this formula in solving the factors. So, sample tayo. Sample. So, say you have x raised to 5 plus y raised to 5. So, if we factor this one, yet we're just going to follow this formula. Ito na sa taas. So, you'd get x plus y times x raised to 4 minus x raised to 3 times y plus x raised to 2 times y raised to, ano na ba tayo? Times y raised to 2 minus x raised to 1 times y raised to 3 plus y raised to 4. And that's the factor. Okay. Maybe another example. So maybe something a bit much more longer. So let's try another example. Let's try this one. 243 times x raised to 15 plus 32 times y raised to 10. So if we could simplify this further, ano yung 243 natin? If you could get the factors of 243 using your calculator. So let's look for our calculator first. Oops, sorry. So ayan, calcu. So from the calculator, let me just move it away. Yeah. So we have 243 equals shift prime factors. So that's 3 raised to 5. So we're going to use that. So that's, we could express this as 3 times x raised to 3. And the whole thing is raised to 5. Plus, prime factors ng 32. It's just, I think 2 times 2 raised to 5. Diba? 32 equals shift prime factorization yan. 2 raised to 5. So, okay. That's 2 times y raised to 2 raised to 5. Okay, yan. So, meron na tayong odd prime. So, the next thing that we're going to do is we're going to apply the formula. Itong formula na to. So, this will now be our x and this will now be our y. Okay. So, let's do that. So, dito ko na lang sa baba ilalagay kasi medyo mahaba. So, our y, or our x rather, is 3x cubed plus 2y squared times 3x squared times, or raised to 4 minus 3x cubed raised to 3 times 2y squared. Hindi kasya. So, sa baba ko na lang isusulat ha. So, plus, so we have 3x cubed raised to 2 times 2y squared raised to 2 minus 3x cubed times 2y squared raised to 3 plus 2y squared raised to 4. Okay, next. So, pag ganito, we're just going to simplify it further. So, from this, you have 3x squared or cubed plus 2y squared. Tapos, simplify lang natin to. So, you have here, so 3 raised to 4 is 81 times x raised to 3 times 4, 12, minus 3 raised to 3 times 2, which is 54. Tapos, times x raised to 3 times 3, 9, times y raised to 2, plus 3 raised to 2 times 2 raised to 2 is 36, times x raised to 3 times 2, 6, times y raised to 2 times 2, 4. Minus 3 times 2 raised to 3, which is 24, times x raised to 3, times y raised to 2 times 3, which is 6. And then lastly, positive 2 raised to 4 is 16 times y raised to 2 times 4, 8. So, yeah. So, that's the factor. Okay. So, I think that's it for factoring and special products formula. Okay, so our next topic is binomial theorem. The expansion of the binomial x plus y raised to n for any positive integral values of n. So note that n must be positive is presented by this formula. So I will not be verbalizing this formula anymore, but please try to read through each and every term. So now we're going to discuss the properties of a binomial. So property number 1, the first term and the last term of the expansion will always be x raised to n and y raised to n respectively, as you can see right here. So you have your y raised to n there, and then you have your x raised to n here as your first and last terms. Property number 2, the power of x decreases by 1, while the power of y increases by 1, as you can observe here. So, the power of x, starting with n, as you move along the terms, so let's say this is the first term, on the second term, it will decrease by 1. And then on the third term, it will decrease by 2. And then on the fourth term, it will decrease by 3, as evident here in our formula. And then for the power of y, it increases by 1. So you started with y is raised to 1, then y raised to 2, y raised to 3, until you reach y raised to n minus 1. And then you have your last term as y raised to n. Okay, so property number 4, there will be n plus 1 terms in the expansion. So it depends, the number of terms in our expansion would depend on the exponent or the positive integral or the value of your n, and then you're just going to add 1. Property number 5, if n is a positive odd integer, keyword natin dito is odd integer, there will be 2 middle terms. And if n is a positive even integer, there will only be 1 middle term. I think it's better presented here using our Pascal's triangle. I think we will get back to that later. Let's proceed with property number 7. So if the coefficient of a term is multiplied by the power of x in that term, and then the product is divided by the power of y increased by 1, the resulting number is the coefficient of the next number. Basically, it is this formula. So you have here the coefficient. So the coefficient is equal to the coefficient of the previous term multiplied by the exponent of x of the previous term divided by the exponent of y of the previous term plus 1. So the way you're going to calculate that is, for example, here in our case, let's say you're trying to compute the coefficient of the third term. So this is the third term. So you have your first term here, second term here, and this is your third term. Diba? So the coefficient of the third term is the coefficient of the previous term, which is n. So you have n here. Multiplied by the exponent of the previous term, exponent of x of the previous term, which is n minus 1. Diba? And then you're going to divide the whole thing by the exponent of y, which is 1, plus 1. Right? So yan yung ating coefficient, which shows right here. And then we have our Pascal's triangle, which represents the coefficients of a binomial. So basically, when you have your binomials raised to 0, raised to 1, raised to 2, raised to 3, 4, 5, and so on, ito yung magiging pattern ng ating coefficients. So kapag raised to 1, isang term lang siya, 1 coefficient. Kapag raised to, or raised to 0 pala, isang term lang, 1 yung coefficient. Kapag raised to 1, it has 2 terms, and then the coefficients is 1. And then kapag raised to, let's say, raised to 4, it has 1, 2, 3, 4, 5 coefficients. As evident, diba ang number ng terms natin will always be n plus 1, which is 4 plus 1, 5 terms tayo. Tapos, ito yung coefficient nila. So, the first term will have a coefficient of 1, the second term will have a coefficient of 4, the third term will have a coefficient of 6, and then the fourth term will have a coefficient of 4, and then the last term will have a coefficient of 1. So, yun lang basically yung ibig sabihin yan. Now, to make the Pascal's triangle, so you start up with 1, tapos you bring that down, so you'd have 1 here, and then 1 here, right? And then you add this to 1 plus 1, you have 2, right? Tapos you bring this down here, you have 1. Bring this down here, you have 1. So again, you just add 1 plus 1, you have 3. Then 2 plus 1, you have 3. You bring this down, you bring this down. So you add this, 3 plus, or 1 plus 3 is equal to 4. 3 plus 3 is equal to 6. 3 plus 1 is equal to 4. You bring this down. And so on and so forth. Hanggang makuha nyo yung desired nyo na coefficients, number of coefficients. Best way, yung balikan natin yung properties of 5 and 6. So this is the best way to visualize this property. So it says here that a positive odd integer, there are 2 middle terms. So the lowest odd integer we have here is 3. So we have 2 middle terms, as you can see. Ito yung middle terms natin. And then you have 5. So the middle terms for 5 have coefficients of 10, as you can see here. What else? The art term of the binomial x plus y raised to n. So it can be solved using this formula. So you have this formula where m is equal to r minus 1, and then your c can now be calculated using this formula. So you could use your calculators using these functions. So let's show them in your calcu. Wait lang, let's load up your calculator. So, okay, in your calculators, you have NCR right here. So you could press, let's say, N natin is 4, shift, NCR, and then your M. So let's say your M is 5. Then you just click, oops, this is supposed to be less, that is 3. And then you just click equal sign, and then you'd get it. So we'll have more examples later using this. Okay, last, sum of coefficients natin. So to get the sum of the coefficients of the terms in the expansion, you're just going to replace x, and this is, wait lang, this is a typo error. So you're going to replace x and y. So this is supposed to be y by 1. So we have an example right here. So you have, actually this is a trinomial. So you have 2x plus 3y minus z raised to 8. Diba? To solve for the sum of the coefficients, you're just going to replace x and y by 1. As you can see, evident here. So we replace x by 1, y by 1, and z by 1. And then you solve this, you'd get the sum of the coefficients, which in this case is 6,000 or 65,536. Okay? So we'll proceed with the examples. Okay, so for example number 1, we are going to expand this binomial. So we have quantity 2a raised to 3 minus 5 times b, quantity raised to 4. So we're just going to follow this formula. So ipa-pattern lang natin yung sagot natin dyan. Okay, so first, what's the problem in this term? So from our formula, as you can see here, well, I hope you can see. Maybe let's make this a bit more larger so that you can read more easily. Wait lang ha. Let me resize this to make it a bit more larger. Yeah. So I think that's enough. Okay. So as you can see here, positive yung sign natin dito sa gitna. So we need to make this positive. And to do that, we just need to rewrite it as, so you have 2a raised to 3 minus 5 times b raised to 4. If we're going to expand that, again, we're going to change this into something, the sign into positive. So you have 2a raised to 3 plus negative 5b raised to, or negative 5b quantity raised to 4. So ganyan. So okay, I think we could use this na in formulating our equations. So let's try this out. So we have, for the first term, you get x. So this is now our x. Wait lang. So ito. So this is now our x and this is now our y. So i-write natin. So x raised to n, you have 2a raised to 3. Our n in this case is 4 plus n, which is 4 times x 2a raised to 3 raised to n minus 1, which is 4 minus 1. So that's 3. Palitan na lang natin. So that's 3 times y, which is negative 5b. And then, plus n natin, which is 4 times n minus 1, which is 4 minus 1. So let na din natin. Then 2. Then for x natin, we have 2a raised to 3 times, or raised to 4 minus 2, which is just 2, times y raised to 2. Oops, yung y pala, iba pala yung y natin. So yung y natin is negative 5b raised to 2. And then, plus again. So we have 4, n minus 1 is 3, n minus 2 is 2. We have 3 times 2a raised to 3. And then this thing is raised to n minus 3. So 4 minus 3 is just 1. Then times y. Again, this is negative 5b raised to 3. Plus, so I think we need to maybe move this one since sa baba pa naman to kailangan. So move ko lang to dito. plus, so where are we na? N minus 1, 3. So, plus y, which is negative 5b raised to 4. So, okay, simplify lang natin to. Let's simplify this. So, you have 2 raised to 4, which is 16 raised to a, 3 times 4, 12, plus 2 raised to 3 times negative 5 times 4. Maybe we should use our calculators here. So, where's our calcu? So, move lang natin. Oops, sorry. So, let's move our calculator dito sa baba. Okay? So, calcu. So, we have negative 5 times 4 times 2 raised to 3. So, we have negative 160. So, let's change this. Negative 160 times a raised to 3 times 3, which is 9, times b. Plus, so we have here 4 times 3 divided by 2. Where is that? So shift exclamation point. There you go. So tama ba? 4 times 3 raised to 2. Okay. Then multiply this by 2 raised to 3 times, times negative 5 squared. That's equal to negative 1,200. Negative 1,200. And then we have, so let's just change this. So we have 4 times 3 times 2 divided by 3 permutation. 2 is raised to 1 na. Oh, wait, I think we got this wrong. This is supposed to be 2 raised to 2 pala. So this is supposed to be 2 raised to 2. Right? Tapos, negative 5 is raised to 2 again. Right here. Ito. So, let's check 4 times 3 divided by 2, 2. Okay. So, let's change this back to 2. So, solve. So, that's negative 600 pala. So, let's change this. So, this is negative 600. So, for the signs, you have a raised to 3 times 2, which is 6, times b raised to 2. And then, minus again. So, let's just add this. So, 5 is raised to 3. 2 now is raised to 1. And then you have the denominator as 3. And then 4 times 3 times 2 equals. So, that's negative 1,000. And then, for the variables, literal or the letters. So, you have a raised to 3. and then b raised to 3. And then you have -5. So quantity -5 raised to 4, which is positive. So positive tayo dito. Positive 6, 2, 5 times b raised to 4. Okay. So that's your expanded term. So highlight lang natin. Okay, I think we missed something. So in our third term, so you have here -5, quantity -5 raised to 2. So this is supposed to be positive. So positive natin yan. Okay, I think we missed that one. Okay, so next example. So we have example number 2. We are to find the third term in the expansion of quantity 2 times a raised to 3 minus 5 quantity raised to 4, which is the same as the first example. So basically, this is what we're supposed to solve for, yung third term natin. Okay, so from here, dun sa ating formula, which you can't see, so let me just move this para makita niyo. So ayan. So ito yung ating formula. So we're going to use this to solve example number 2. So first, ano ba yung given sa atin? So we have your n, which is basically equals to 4. And then you have your r, which is the third term. So that's number 3. And then you have your m, which is 3 minus 1. So that's equals to 2. Right? And then you have your c and m, which is basically, so you have 4. Tapos, in our calculator, from the calculator, NCR times 2. So, if we solve this in our calculator, so let's do that. Calculator. So, from the calcu, so we have 4 shift C times 2. And that's equals to 6. Okay, so we're going to use this formula in solving the R term, which is the third term. So we have the third term. So that's equals to 6, or 6 times x. So in our case, again, we're going to rewrite this term para mag-positive siya. Ganito. So ganito yung lalabas. So our x now is equal to 2a raised to 3 raised to n minus m. So our n is 4 minus 2 times y, which is -5 times b raised to m, which is 2. So if we simplify this one, you'd get 600 times a raised to 3 times 2. So that's 6 times b raised to 2. So that is the third term, as we can confirm dito sa ating first example. Okay, so what if reversed? As in example number 3, we're going to find the term involving x raised to 3. And the expression x raised to 2 plus 1 over x raised to 12. So, paano pagbaligtad na? So, we're still going to use the same formula. Reverse lang yung magiging approach natin. So, from the given, so let's write down the given. Yung n natin is now equals to 12. The r, hindi natin alam. M is equals to r minus 1. And then our c and m, we don't know. Diba? So, ito yung alam natin yun. So, from our formula, so we could use our formula. So, basically, it says here, yung given sa atin, R term is equals to x raised to 3, right? So, x raised to 3 is now equals to, so yung ating C and M. So, maybe we could use this formula instead. So, pero kasi it says here, ito kasi yung coefficient. This is for the coefficient of your term. But since yung term na hinahanap natin doesn't actually have a coefficient. So, in our case, yung ating C and M would be equal to 0. Kasi the R term, the one we're looking for, is equal to x raised to 3. So, ang coefficient niya is actually 1. So, we don't need to solve for this one because it's equals to 1 na. Diba? So, we could proceed with this part of the formula. So, ang ating x is actually equals to x. Oops, palitan natin ang color. So, we have x raised to 2 raised to n. So, we have 12 minus m, which is r minus 1. So, this actually becomes positive. Times y, which is x raised to negative 1 raised to m, which is r minus 1. Okay. So, from this, pwede natin, maybe we could further simplify this one. So, tama ba? Ang n natin minus m. Right. So, I think we could further simplify this. So, we have x raised to 3 is equals to x raised to 2 times 12 minus r plus 1 times x raised to negative r plus 1. Tama? So, by default, from this, if you would remember your law of exponents, diba? So, from your law of exponents, diba, sabi, if x is raised to a times x raised to b, then this is equals to x times or raised to a plus b. Therefore, we could actually equate this. So, x times b is equals to a plus b. Diba? So, we could use that in solving for r kasi that's what we're actually looking for. So, for r, we can now solve this as 3 is now equals to 2 times 12 minus r plus 1 plus this is negative r plus 1. So, solving for r, shift solve lang natin to. So, our calculator. So, wait lang. So, we have 3 is equals to 2 times 12 minus alpha x plus 1 quantity plus negative alpha x plus 1 quantity. So, shift solve equal. So, our x now is equals to 8, which is actually equal to our r. So, ibig sabihin, we're looking for the 8th term. Right? So, if we're going to solve for the 8th term, so gamitin lang natin siya dito sa ating equation. So, we're going to use r is equals to 8 in our equation. So, now, So, ito, 8 na to. R minus 1 is 7. Diba? C and M is now equals to, so we have N, which is 12, shift C, our M is equals to 7, equals, so that's 792 na siya. Okay? So, our 8th term is now equals to 792 times x, which is x squared, raised to n, 12 minus m, 7, times y, which is x raised to negative 1, raised to 7. So, simplifying this, we have 792 times x raised to, so 12 minus 7, you get 5, x raised to 10. And then from this, you get x raised to negative 7. Simplifying this further, you get 792 raised to, or times x raised to 10 minus 7, you get 3. Okay, so I think that's the final answer. So this is the term in the expansion of this that has x raised to 3. So that's the final answer for this example. Okay. So next topic, we have the quadratic equation. So for the quadratic equation, there are actually about different ways on solving for the quadratic equation. One of them is factoring, other one is completing the squares, but what we're actually going to use is yung ating quadratic formula. So, pero kasi, in our calculator, we could actually now solve directly for the roots just by using our calculators. But it is helpful to know na ito yung ating equations. So, this is our quadratic equation. It is arranged in such a way. So, meron tayong arrangement. So, you have x raised to 2 here, coefficient A times x raised to 2 plus coefficient B times x plus your constant C, and the whole thing is equal to 0. So, that's your quadratic equation. Now, this one is our quadratic formula. The quadratic formula is what we're going to use to solve for the roots of our equation. So there are two roots for the quadratic equation. So meron tayong conditions. First, we need to know na ito, ang tawag dito, b squared minus 4ac is actually called the discriminant. And that discriminant actually determines kung ano yung magiging roots natin. So we have our condition. So the first condition is if b raised to 2 is equal to 4ac, then our roots are equal. So they are both rational and they are also equal. Next, so we have here if b squared is greater than 4ac, then yung ating roots are actually irrational and unequal. Tapos, yung last condition natin is if our b squared is less than 4ac, then the roots are imaginary. So, another shortcut formulas that we could use. So, for the sum of the roots, it is just equals to negative b over a. And for the product of the roots, it is just equals to c over a. So, maybe I could show you how to solve for the roots using your calculators. Sige. So, let's do an example. So, example number 1, let's try 6x squared plus 10, or rather 11x is equals to 10. So we're going to solve for the roots. So the first thing that you need to do is you need to rearrange this in such a way that the whole equation is equals to 0. So you have 6 times x raised to 2 plus 11x minus 10 equals 0. Now this becomes our A, this becomes our B, and this becomes our C. So we could actually further rewrite this one. So para hindi to negative, ang gagawin natin, so plus negative 10 equals to 0. So this will now become our C. Diba? So using our calculator, where's our calculator? Here's our calculator. So what you're going to do is you're going to click mode. And then you're going to click 5 for the equation, yung EQN. And then you're going to click down, the arrow down. And then you're going to click 1 for the quadratic equation. And then you're just going to input the values. In this case, yung A natin is 6 equals, B natin is 11 equals, C natin is negative 10. Negative 10 equals. And then press equal. X1 natin. So let's write that down. So you have X1 is equals to 2 times, or 2 over 3. And our X2 is equals to negative 5 over 2. So check natin. Let's compute for the sum of the roots. So for the sum of the roots, you have X1 plus X2. So that's equals to 2/3 plus negative 5 over 2. Diba ang sabi dito sa equation natin, it is just equals to negative 5 or negative b over a. So you get 11 over 6. Oops. Sorry, hindi pala nakikita. Let me just move this dito banda. Okay. So, balik tayo. Mode. Comp. So, let's check kung tama itong formula natin. Kung ito ba talaga yung lalabas. So, 2 over 3 plus negative 5 over 2. And it's equal to negative 11 over 6. So, tama. What about product of the roots? So, x1 times x2 is equals to 2 over 3 times negative 5 over 2. And that's just equal to c over a. Diba? C natin is negative 10. A is 6. So, solving for that, so multiply lang natin to. So, you'd get negative 5 over 3. So, tama. So, if you simplify this further, you'd get negative 5 over 3. Diba? So, tama yung ating formulas for this one. So, that's it. Very basic yung quadratic equation natin. Kasi you could use your calculators for this one. Okay? So, our next topic, ratio and proportion tayo. So, let me just hide our calculator. So, ratio and proportion. So, what is ratio? So, ratio is the ratio of one number, A, to another number, B, denoted as A is to B. So, it is the fraction A over B, provided your B is not equal to 0. Now, a proportion is an equality of two ratios or fractions. the proportion denoted as such is read as A is to B as C is to D. So it can be written in two ways. So you could write it in this manner, or you could write it as fractions. So yung nasa loob na terms here are actually called means. And then yung nasa labas, yung outer terms natin are called the extremes. Now for the laws of proportion, so ito yung ating laws of proportion. If A is to B as C is to D, ito yung ating laws of proportions. So you have 6. So if yung first law natin, A times D is equals to B times C. Second one is B over A is equals to D over C. The third one is A over C is equals to B over D. And then the fourth one is equals to A plus B all over B is equals to C plus D all over D. And then the fifth one is equals to, or the fifth one is A minus B all over B is equals to C minus D all over D. And then lastly, you have A plus B all over A minus B is equals to C plus D all over C minus D. Okay, next, we have principles of variation. So we have three different types of variation. So the first one is a direct variation, where X is directly proportional to Y. So we could assume that there is a K, which is a constant of proportionality. So our formulas are this. So we have X is directly proportional to Y, or X over Y is equals to K, or X is equal to K times Y. Now for the inverse variation naman, we have here X is inversely proportional to Y, or this is the same thing, X is inversely proportional to, or proportional to 1 over Y, or we could say that X is equal to K over Y. Now for joint variation, we say that X is directly proportional to Y and inversely proportional to, say, Z squared. So this is the same thing. So X natin is directly proportional to Y over Z squared, or X is equal to K times Y over Z squared. So let's try and solve some problems, some example problems. So for number 1, if Z varies directly as X and inversely as Y, and if Z is equal to 10, when X is equal to 5 and Y is equal to 3, find X when Z is equal to 12 and Y is equal to 4. Now to solve this, so let K be our constant of proportionality. So constant of proportionality. Then the given condition of the problem is translated as, so we have Z is equal to K times X over Y. Or we could also say that K is equals to Y times Z all over X. So substituting the given, we can get K, which is, so solve natin yung K natin, our Y, so it's equal to 3, and Z is equal to 10, divided by X, which is equals to 5. So ito yung first case scenario natin. So it says here that Z varies directly as X and inversely as Y. So ito yung relationship na yun. And this one. So from this relationship, we brought out our constant of proportionality to produce this equation. Now for the first case natin, Z equals to 10, X is equal to 5, and Y equals to 3. So from that scenario, we can now compute for K, which is equal to 6. So 30, 3 times 10 divided by 5 is 6. So from that equation, we can now solve for the value of x. So we could solve for that. Still, we would use this equation. So solving for x lang tayo. So we have here, so since k is equals to 6, our y now is equals to 4, and our z is equals to 12, all over x. Now solving for x, so this is just 4 times 12 divided by 6. So that's equals to 8. And that's the final answer for example problem number 1. Example problem number 2. If 2 men can repair 6 machines in 14 hours, how many men are needed to repair 18 machines in 8 hours? So we're asked how many men. Okay, let us assume x is equals to the number of hours and y as the number of machines, and z as our number of men. So we could say that z, or rather x, varies directly as the as y, and inversely as x. So we could interpret that as x is equals to k times y all over z. So from there, so ang ano kasi sa problem, 2 men can repair 6 machines in 14 hours. So yung number of hours natin is directly proportional to the number of machines. Tama? While your ano tawag dito? Your number of men is inversely proportional to the number of hours. So ito yan. Now, from this equation, we can now solve for k, which is the constant of proportionality. So from this, so ang x natin, so on the first case, you have 2 men that can repair 6 machines in 4 hours. So ang x natin would be 4 hours. Our k, we don't know our k, so we're trying to solve for k. Now our y as the number of machines, which is 6, divided by z, the number of men, which is 2. So solving for k, so our k would be 4 over 3. So from this equation, we can now solve the number of men that you'd need to repair 18 machines in 8 hours. So we're just going to apply that. So yung x natin, or we could bring out yung z natin. So let's bring out our z na lang. So our z, so we're still using this equation. So our z in this case would be z is equal to k times y all over x. So solving for z, our k is 4 over 3. Our y in the second case is 18 machines, so that's 18 all over x, which is 8 hours. So that's 8. So lagay lang natin sa parentheses yan. Okay, now what would now be our number of men? So that would be equal to 3. So 3 men. So let's highlight that. Okay. Example number 3. So a simple interest varies jointly as the ratio of interest and the time that the money is invested. So first statement muna. Sabi, simple interest varies jointly as the ratio of interest and the time that money is invested. So let's say simple interest would be X, the ratio of interest would be Y, and the time that the money is invested would be RZ. So let's write that down first. Okay, there you go. So from that statement, we can now say, or we can now use this formula. So it says that our X varies jointly, to our ratio of interest Y and our time invested. So from that expression, we could now use this formula. X is equals to K times Y times D. K being our ratio of K being our constant of proportionality. So from this equation, we could solve for K, which is just equal to X all over Y times C. So for the second statement, an investment at 12% for 2 years earns 280. So we're going to use the second statement to solve for our constant of proportionality. So our X in that statement is 280 divided by Y, which is the ratio of interest. For that is 0.12 or 12%. And our Z, or the time invested, is for 2 years. So our K is equal to 1166.66. So from that equation, we could now solve for our question. So how much will the investment yield at 16% for 4 years? So we're just solving for X. So solve natin yung X natin. K is equal to 1166.66. Y natin, ratio of interest, 0.16. And our Z is 4 years. So from that, our answer is 746.67. So this is in PHP. Okay, so that's the final answer for example number 3.